Hey, we are Liam and Kieron, and our project was increase of toxins in marine algal blooms. And let's get started. How red tides occur is the main way that toxins are able to get into the ocean is due to rain and sprinkler systems. Rain and sprinklers are able to take pesticides off of crops, and those pesticides travel with the water, mainly along roadsides and eventually to drains or sewers. Also, because cities carry many pollutants, the water gathered in cities tends to be very toxic. This largest issue is when the toxic water gets to the sewers or drains, because from there, most of the water is dumped straight into the ocean. When these pesticides and pollutants enter the ocean, the process for forming red tides occur. These red tides are harmful algal blooms because the toxins cause the algae to reproduce too quickly, and most of the oxygen is depleted, causing the release of toxins in the air and water. Since there are so many toxins, the algae pigments become discolored. These algal blooms are usually red but can be brown or green. You can see an example of the more common red tides at the top left. You can also see examples of the green tides at the top and bottom right. At the bottom left is an example of a brown tide also mixed with the green tides. As you can see, all of these are on the coast or near land. This is because all of the toxic water is released into the oceans by drains right next to the land. These harmful algal blooms are able to occur in marine water and also fresh water. A lot of people have tried to attempted to prevent or change this issue. One of the which is kind of shown at the top left is a sensor that can track and predict where and when the harmful algal blooms will occur. This sensor can read the genetic material of the algae and identify the 3 harmful microscopic types that can occur. This device will give an early warning when it detects this. This can help scientists reduce harm to humans and marine life. Another idea that has been proposed, as shown at the top right, has been floating treatment wetlands. The idea is that a large sum of floating mats will be put into the water source, like the sea or a lake, with the wetlands plants growing on it. The roots of the plants will filter and contain nutrients, and that will help the biofilm processes that will reduce the levels of cyanobacteria. This will lower the risks of the HABs by balancing the nutrient levels. The limitations to this will be that this is dependent on how many mats and plants there are in the water. The issue is if there are too many, it will take too much oxygen out of the water. Another method that has been tried, is shown at the bottom middle, is aeration and mechanical circulation. They can both interfere with the water column, taking away prime conditions for algal blooms, but the issues with this is they both have a limited range because you have to put it around the area, and then the aerator could harm the inhabitants that are relying upon a cooler environment. Mechanical circulation could actually cause an algal bloom because some of the algae will thrive off the circulating water. The other methods for prevention, which is shown at the bottom right, and how they work, is to add alum, ferric salts, or clay to reduce the phosphorus levels in the water column and cause the cyanobacteria to settle. At the bottom left, you can see how they tried the barley straw, which will be placed in a buoyant net around the water. And as long as the barley straw has water and oxygen, it will create chemicals that prevent algae growth for quite cheap. Some of the issues that could arise from these algal blooms is that the fish species around the world is already collapsing. As you can see on the far right, that since between the 60s and the 90s, the density of fish has greatly declined. And in the middle, you can also see how the fish have declined, and the extrapolated long-term trend is quite scary. So the algal blooms will kill these fish, which could add to the problem even worse. And on the left, you can see at all the places where PSP, a toxin to the fish that is produced by algal blooms, where it has been found from algal blooms all over the world. As you can see, it's in pretty much every continent, so it could kill a lot of fish. Another issue is that algal blooms will take the oxygen out of the water in the area and then put in toxins. As you can see on the left, as the globe gets warmer, the oxygen content of both fresh and seawater will go down. And then most of the oxygen in the earth, about 60 to 85% around the world, comes from the water. So if the algal bloom takes out the oxygen, the air could become thinner, and will even become thinner as the climate change continues, as the oxygen levels decrease. As you can see, as there are becoming more algal blooms, as shown by the graph in the middle, this will only get worse. And on the right, it will show that A huge issue is that the harmful algal blooms could harm our water resources, and as the water resources are already falling, it could get even worse with this. And then everyone is using more water, so it's not going to work. Our solution involves taking our toxic water and purifying it for reuse. The toxic water that is collected from polluted cities and pesticide-filled farms will run down the road like usual. But when the water gets to the drainage systems, some will be rerouted by drains and go to a purification plant. Of course, most of the water cannot be collected because the plant can only process so much water at a time. The first stage is water distillation. This will remove all volatile compounds that can be removed from the water by evaporation. Then the water moves to the reverse osmosis process. This will remove toxins that have not been removed by the distillation process. From there, the water can be reused. In 1 month, Orange County uses 14 million gallons of water. If 10 of these plants are built in Orange County, 4 million gallons of renewed water will be able to be reused. 10 plants will cost about $6.9 million, but will pay for itself and some. With the money saved during this process, we can build more plants and provide more water from the dirty water that would have gone to the ocean is now being used by us as clean water. Thank you for listening.